Here we are going to study AND gate. Everyone knows AND gate. This is a logical gate where in this case we have considered two input, bit A and bit B. As we know, as the logic AND says that if both of the bit, that is bit A and bit B, is true, then only the result will be true. Here we are used to uh, implement AND gate in various kind of situation, but in this case we are implementing AND gate using ladder logic. Here in ladder logic you can see there are two input devices. We call it as NO switches, which can be shown as bit A and bit B, and the output is shown as result. Here we know as per the logic of AND gate, if both the input are true, then only the output will get on. So if bit A and bit B both become true, then only our result will be displayed on the screen. Here I want to say that here we have two NO switches, the bit A and bit B. It becomes true when they are pushed. Just try to imagine that there are two push buttons which are NO type. If we push both the buttons simultaneously, then only our output, let's say we have a lamp, then the lamp will get on. Now we will try to see OR gate. We know in OR logic, if one of the input is true, then the result will be true. Same thing we are implementing using ladder logic. Here we have to understand when we are saying OR logic, here we have to implement the circuit in a parallel mode. Hence we have connected two NO switches in parallel operation. If one of them get true, then output will become true. This gate can be used by various conditions, like if you want to operate one motor with two different switches, we can use this logic. Let assume that result is our motor and bit A and bit B, these are the two switches. If you press any one of them, then motor will get on. This is the implementation of OR logic in ladder diagram. Now we will try to understand another logic, that is NOR gate. Here we have to understand that if both of the input is not operated, then our output will get on. If any one of the input is operated, then our output will be off. Here you have to understand that there are two NC switches are used, because whenever we say that there is no input, still our output should be on. Hence we have used here NC switch. If we have used NO switches over here, then definitely at the 0 0 condition our output will not get on. Similarly, if you consider NAND gate, here you can understand where the input, if they are in off condition, our output should be on, and if any one of them is off, till our output should get on. So hence we have implemented these two gates, NOR gate and NAND gate, using ladder logic. Here we have to understand, if you operate a output without pressing a push button, at that case you have to use the NC buttons. Continue with the same example. Here are little bit introductory term related to a ladder logic, where we have to understand the ladder logic. Here as shown in diagram, you can see there are vertical lines and horizontal lines. Vertical lines, the vertical lines are called as rail. There are two rails, one is for positive side, one is for negative side. In horizontal line we call it as rung, where we are placing our input as well as output devices. Every device has a name as well as address. If you say I 0.0, it indicates it is the input and it is the first device. If we say that is a second device, then it will be I0/1. If it is a third device, I0/2. This kind of addresses will be given for every programming. Different kind of instructions are there, but the logic will be same. And we can also give the name, like if it is a push button, we can say push button. If it is a sensor, we can say a proximity sensor. Such kind of name can be given for every input as well as output devices. So this is all about ladder diagram and implementation of ladder logic using the ladder diagram. I hope so you have understood this. If you have any query, you can contact me.